Last period, there's number 2. Let's talking about last period. I was saying, yeah, nope, I don't want a horse because they're too expensive. But then I was joking and saying, well, in fairness, horses are quite expensive. However, this morning I was also talking about really wanting to get a green-winged macaw. And so if expensive is the only criteria, I think I'm probably up a creek. Yes, ma'am.
Asymptote x-axis, can you put horizontal asymptote?
You can, yeah, yeah. It only has one, but yes. Yeah, that's still correct. That's.
So if I put horizontal asymptote at 0, that's correct?
Yeah.
Okay.
Oh, like at x equals, or at y equals, you would want to put y equals 0. Because that would be the line.
Increasing or decreasing?
I don't know. Just scribble
Oops.
and that's all around.
Number 4.
Oh, I wasn't done.
Oh my gosh. If y'all are going to be slow, I'm going to have to make me another coffee.
Why is it 0 infinity?
Y is what, sir?
The range, doesn't it never?
So, no. There's an asymptote, right? It never actually gets, so it's 0 to infinity, but not including, that's what the round bracket means.
Oh, yeah.
Yeah, so if it was a square bracket, it was a square bracket, whatever that means. Yeah. All right, number 4. Same thing-ish. Very.
So it's 0 to infinity now.
It was 0 to infinity. Oh, you wrote it this time. Nice. Good job, Garrett. Progress.
I don't know why.
Number 6.
Yeah, I give up.
Why? Don't give up.
Because I haven't done.
What are you missing?
The limits? Limits are
Yeah.
looking at.
Isn't the limit the same as the other one?
They're all, on these first 3 that we've looked at, the limits are all the same. So, well, this is the 3rd, but yes. The limit as x approaches negative infinity is 0. And the limit as x approaches positive infinity is positive infinity. Right? It's the same. It's the, on all 3 of these, it was the same.
Which I did wrong.
End behaviors. Why I didn't come back. Yes, it is, but we got to flip the page, so give me a second. Take another picture. I'm ready for my close-up, Mr. DeVille. Famous. Right there. Star is born. Yahoo and such.
So blurry. Oh, that's so blurry.
It's good enough. That number is 1/3.
Where?
Was like all of the where. This is 1/3.
I have it corrected now, that's fine. I'm just kind of going on the assumption that since I have everything else right, all my numbers are right, since I did -5,
Right.
2, and 5 to get a general range for everything every time.
Right.
Where's that?
Number 10.
2. Yeah, I got that.
Excuse me. Number 12 is easy money. Oh! Oh no! The unicorn is slow. What is the matter, Bree?
I can't see it.
What do you need to see that you can't see?
The D of X.
This is what it looks like to need glasses right here. The limits, as x approaches negative infinity, the limit would be positive infinity. The limit as x approaches positive infinity would be 2.
I have a friend who's got like a
What?
-7 prescription.
Oh, really? Wow.
How?
I don't know how she like turns. She's a
Looks
dancer,
like,
too.
it sounds like she needs some bottom glasses.
She doesn't-
There's number 12.
What did I do?
Easy money.
Oh, I did 11. I did 11. I did 11 as well, because that is not the numbers. We don't get 11. No,
11 is that.
No, I didn't do 11, but I did 13.
Well, 13 is there.
Got it. Hold those and then you ask how you actually phrase this.
14 is this one. Translated 2 units to the right and 5 units up.
Why? So I got 5 units up.
Did you get the 2 units at all or no? Like in any direction?
What did I write?
That I don't know. That I don't know.
So 2 to the right.
Didn't come back.
Oh no, I said 2
Don't
down,
know
right
why.
5.
Mixed them up.
I said 2 down,
Yeah.
right 5.
You flip them around. 16 is these away. It's tricky because it's horizontal compression, right? That's the thing we're adding in this class that's different than what we get in Algebra 2. We don't really get horizontal compression in Algebra 2. The E, yeah. You punch
Are
E.
you saying
E is just a number.
sketched it in the same graph and did
2
the
point-
extra graphs?
218 something. It's like pi. It's irrational.
I didn't think of that.
What are you asking?
I forgot. I didn't realize that you could sketch it in the same graph.
You can.
I did 2 different.
That's fine. It's easier to. It's actually easier to compare it if you do put it on the same graph. So it's probably actually easier to put it on the same, not just because of space, but it's
Yeah.
easier to compare what happened, right? Yes, you can. Definitely recommended. Number 18.
You should have.
Nice little reflection, right?
Oh.
Okay, reflected on the y-axis also be horizontally reflected.
Yes. Yeah, I would argue that's fine.
Not entirely sure.
Yeah, I like the wording. That's fine.
I like the wording, but like I wasn't entirely sure if I understood what it would mean for horizontal. vertical.
Right. So the vertical, right, would be like in front. So if the negative would have been, I may be answering a totally different question than what you're saying. But if the negative was here, it would be a vertical reflection. But the negative on the X is a horizontal one.
That's what determines it.
Yeah.
'Cause I wasn't sure exactly what determined it, but I also wasn't sure like what it would, since I didn't know what it meant, I just like based off the visuals, so I'm like,
Right.
I'm not sure which
Right.
line determines what.
We went through 24, right? Is that correct?
Yep, so
Okay.
20, 22, and 24.
Okay.
Those are the non-compatible.
Hello, machine.
The last 2 weren't hard, they were just really tedious.
Oh, I don't know.
20 is that guy.
Yahoo.
Excuse me. And 22 looks like that. And probably, does it have other parts to it? What does it say?
No, that's it.
Play the table. Oh, just kidding. Yeah, there you go. Easy money. 22 is like that. Oh, shoot. Just kidding. The only one that you have to do anything other than just read the calculator is the last one. And number 24 is that one. Again, most of it you just put in the calculator. That very last one you'd have to show some work
So how do you do it?
with the formula.
The last.
You talking about the entire table or the last one? What?
Oh,
Kind of forgot that you
So-
put it in the calculator. Like not like in a table. I just put the numbers in every time.
Okay, so what questions? We might end up starting with that, but what questions do we have on this lesson?
start with
Did we do 2? We just did 1, right? Am I dreaming? Did we do just 1 lesson?
Yes.
Yes? Okay.
16.
16, he says. Let me swivel Aiden around. Whoosh. Why didn't come back? 16. Número 16. Excuse me. 16 is f of x equals e to the x. E to the x is such an awesome thing. If any of you do calculus, you're going to love e to the x. Because the derivative of e to the x is e to the x. E to the x is so fun.
I'm sure that is something I'll appreciate at a later time, but I do not understand right now.
It's likely to be true. Well, it depends actually on which of your 5 careers you end up going for. Well, e to the 2x, right? Is that correct? Yes, maybe, yes. Great. So we are supposed to use the graph of f of x to describe the transformation that results in the graph of g to the x and sketch the graphs. So you should, to be clear, this es muy importante. You should, if you cannot, then put the crutch away until you can, but you should be able, on these transformation things, no matter whatever the graph looks like, you should be able to look at that and tell me what's going to happen without the graphing calculator. You obviously can use the graphing calculator, but if you cannot do that without, then we need to put the calculator away for a minute and make sure you understand where and how the transformations happen, right?
Go over that.
Yeah, so we'll put it in a generic one, yeah? So we'll even use this function. So the transformation bit, the generic looks like this. A times B, no, what do I want to use? Do I want to use B? That's, I'd rather use B up there. So let's use A times, what is something that isn't used? M, that sounds fine. To the BX minus H plus K, right? Now, this is the same, to be clear, and this is why I'm gonna say this is the same transformation thing as if it was this equals AX minus BX minus H squared plus K. It's the same if it was a square root. It's the same if it's cubic. If it's the same if it's linear, actually. It's the same if it's anything. They're all the same. These letters are the same, right? Now, depending on the book you're using and whatever else, like the actual letter they use, A, B, K, and H, may be different, but the position is the same, right? So the one in the front, the A that I'm using, what does that do?
That determines whether or not it is vertically reflected.
So vertical, we'll start with that. Vertical reflection and also does what? So what is that called? The stretch and compress. What is the word for both of those? What happens when your eyes get bigger? What's that called? Dilation. Okay, reflection and dilation. Okay. Now what about the B?
That's horizontal.
Yeah, so it's no, that's the H is what you're thinking. So the H is horizontal reflection and dilation. Not all. Horizontal reflection and dilation. Right? Now what about the H?
Vertical.
No, it's still in the parentheses, right? So it's still horizontal. Yeah. Translation is a T word. Shift is also fine, right? So it is. So is the B, actually, but horizontal translation. What does the K do?
Vertical.
Vertical translation. And that's true no matter what the parent is. We're going to learn here pretty soon. Actually, I started working on yesterday. I would be done yesterday if I wasn't fighting with technology for a little bit yesterday. But on the last video in this short unit, I don't know if you've noticed, I warned this already, but this is a short unit, which means test comes quickly, right? Which also means there's less on the test. So, you know, silver linings and all, whatever. Okay, so, excuse me. Oh yeah, whatever parent you have, the last lesson, I'm actually working on making my own video because I don't think there's one that's going to present that material quite the way I want to present it. So I'm working on that video, started it, it won't take me too long. I'm actually going to use Excel, it's going to be fun. But no matter what the parent is, no matter whether it's squared, no matter whether it's square root, no matter whether it's exponential, logarithmic, et cetera, et cetera, et cetera, or some weird hybrid, right? We saw that in the last unit where it's maybe not quite so cut and dry and clear boxes as what we said in Algebra 2, right? No matter what, these always do what they do. Mostly, unless they don't. But they pretty much always do what they do, right? And they do what they do enough that you can kind of put that as a pseudo rule in your brain, right? The only thing that shifts is where the quote unquote parentheses are, right? In this case, it's literally in parentheses. In this case, it's in the exponent. In a cubic, it would be in parentheses. In the square root, it would be in the square root. In the absolute value, it would be inside the absolute value, right? Right, so it's where, but that's the inside and outside, right? Making sense? Okay, back to this problem. Yes, it's a horizontal what? Not a translation. Dilation. That's true. Is it going to be a stretch or a compress?
Stretch.
Okay.
How? It's just a variable.
It's not just a variable, it's a two variable. Yeah, on these, the f of x is where it starts, and so how does it change from this to this? Is what it's saying. Yeah.
Stretch because it's more than one, right?
Right. Horizontal stretch. And then we can confirm that with a little chart, right? So let's make a little chart. Let's do, and we'll even compare it this way. We'll do a comparison chart. So we'll do x, f of x, g of x. And we can do kind of our own standbys really, because we're going to have irrational numbers because E is irrational, right? So they're going to be ugly. All right, so we can just do like -2, -1, 0, 1, 2. If that doesn't give us enough information, then we start shoving more on there, right?
Do you want me to tell you what they are so you remember?
I'd love that.
So for f of x, -2 is 0.135.
Yeah, 0.135.
-1 is 0.367. 0 is 1.
Yes.
1 is 2.71. 2 is 7.3.
2.72. Liar.
Sure.
Because it's 2.718, right?
How do you do that in your head?
Because I know what E is. I know, well, to that mean it's like, because E is just like pi. It's where it's, pi is 3.14159. E is 2.718.
Okay, then 2 is 7.39.
7.39. Okay, so what about G of X? Let's find those.
0.018.
0.18.
0.135.
35. 1.
7.39.
Surprise, surprise.
89 if you want.
It's what now?
Or 389 if you want. I don't know, I rounded it up for some reason.
That's fine. We're not going to have that amount of resolution anyway. We may as well write 7.
54.598.
0.598. So horizontal stretch. Let's take a look at it. See what happens. See if we're right. If it is a horizontal stretch, or maybe we're wrong. Let's find out, shall we?
It is.
Is it, though? Is it a horizontal stretch, though?
Yes.
Well, let's take a look and see if you're a liar. You might be. You might be not. We'll find out.
Wait, am I doing which one?
I'm going to do this one in red. And this one in something reasonable, brown. Why not? It's not at all reasonable, but we'll make it work. All right, so negative
Oh, it starts out stretched and then it gets skinnier.
2. So the red is negative 2, and so right there-ish, negative 1, and a little higher than that. And then goes through here. And then at 1, it's at 2 point something, so here-ish. And then at 2, it's at 7, so that's 2, 3, 4, 5, 6, 7, sure, right there-ish, right? Good enough.
So it's actually compressed.
Yeah.
Horizontally, yes, it is.
I was looking at the wrong function.
And then this is a little,
Right, they're these
ooh,
inverse in the.
yes, she got it. And here it's all the way up here. And there it's way up there. So it did opposite of what your brain wants it to do. Because inside the parentheses, opposite, inside opposite, yeah? So inside, that is a horizontal compression, which would be the same as a vertical stretch, right?
Yeah.
Yep. Inside opposite. Aren't you glad you have graphing calculators so you don't have to like have that whole chart of stuff memorized? You can cheer Britton and Lillian on. You can do it.
They keep saying, I don't know how you were happy last year. This is hard.
You were whining the whole year, so I don't know what they're talking about. Okay. Any other questions from this lesson?
No, I like the number stuff more than I thought I would.
Nice.
Can we?
I guess that's good if I want to try to do accounting.
Right? You know, the math in account, now you'll have to take some like ugly classes like business math 1 and 2, but the actual math you do in accounting is like 8th grade math. It's like easy stuff. You'll have to take business math 1 and 2. You'll have to take stats and some stuff that's got crazy stuff and whatever else. But in your actual job, you'll use like Excel and arithmetic. Easy money. Okay. What other questions from this lesson?
I keep doing F and G accent instead of G of X.
That would be something totally different. Garrett, I was thinking about you this morning. You've continued to grow every year in math. You're doing better and better. If you want to do something with math in college, you could. I'm telling you right now. You could do it.
Grades aren't showing it.
Your grades are showing, your work is showing the change. Go put, do you have any of your old stuff from like pre-algebra and algebra 1 and like, I'm telling you right now, you go compare the types of mistakes you made then to the types of mistakes you make now, you're growing. You know, actually, Rochelle was telling me the other day that, I don't know if she may have told you this too, who knows, but she told me that you actually kind of remind her of Kevin a little bit. Because actually, believe it or not, I didn't have Kevin for math, but believe it or not, Kevin was like, not like picking stuff up really fast in high school. Oh, and look at him now. So you can do whatever you want to do. You may not want to do any of that,
Definitely don't.
but if you did, you could. Any other questions from this lesson? Sounds like mostly no.
Not really. But what are we going to be doing for Thursday? Because I haven't decided yet.
We're going to be doing logarithmic functions.
Oh no.
Yay.
I love logs.
A logarithm.
Well, let's preview that. Why not? We got 10 minutes. You ready?
1 second.
You want to start notes?
Do you want to not waste the next 10 minutes? Then sure. But it's up to you.
That's a good idea.
Is it one of your videos, or is it other person's video?
I don't remember. I think it's both.
Yeah.
If I had to remember.
Is it an algebra 2 video?
Yes, it is. Oh.
Last year. I didn't.
I should have. I might steal Christie's.
I can send you a picture of mine.
Of course, Christie's were from the summer, so who knows.
That's true. Oh, I probably get a piece of paper.
Mayhaps.
I'm running out of paper, Sean. I didn't think you meant it when you said we would need a lot of paper. So I didn't think we need that much more than that too, but
It's notebook paper, you can get this by like
Well, yes.
hundreds.
yeah, my mom doesn't do that.
The concept of it, so.
Nice concept. I'll be thoroughly honest. We haven't had to buy paper in forever because one of my mom's friends who works at like an office building, and one time they over-ordered on printer paper, and so we have had like the chunk of printer paper for like 5 years now, and we've never had to get it anymore. Like, I know
Nice.
that's not notebook paper, but like same concept.
Nice.
Yeah.
Okay, so logarithms are kind of the inverse of exponents. Kind of. Okay, so switching between exponential form and logarithmic form looks like this. If we have b to the x equals a, we could turn that into the log base b of a equals x. So the difference, and the key difference and the biggest important idea is that logarithms focus on the exponent. The focus and the emphasis is on the exponent from the exponential form. And it lets us, and the cool thing about logs when we get to, when we graph logs, you'll see that they are inverses of one another. Like if you graph exponential function, you graph a log, it's just the inverse. In other words, it just takes the exponential growth and it flips it over the x-axis and it looks like this instead, right? Which is what most of this lesson is about. But I'm going to kind of hit some of the possibly less developed things now. Okay. So there's a few basic properties of logarithms that relate directly to the same properties in exponents. If we have the log base b, so any base, of 1. So let's think about this as a logarithm. What can we raise anything to and get 1 as our answer? Yeah, so log base anything of 1 is always 0, always. Okay.
Log base anything of 1 is always.
Yes. Now if I have the log base b of b, so what can I raise something to and get the same thing? 1. So if the base and the argument match, then it's 1. Log base 3 of 3 is 1. Log base quartile of quartile is 1, right? Whatever it is. Yeah? Easy money. Did you say base binary? What'd you say?
Looks like binary.
Yeah, kind of. Yeah, it's base b, sure. Of course, you would usually write 2. Oh, but 0 and 1 was specifically what you were talking about. Yes. Yeah. Binary is fun. The log base b of b to the x. Now we're going to learn another way to do that thing. But log base b of b to the x is x. And this is a preview from past and future all at once. But you're going to be reminded or learn a property, excuse me, a property that lets us, if we have the log, whatever the base, HB of x, we can take this x and put it out to the front. So this could turn into x times the log base b of b. And this is 1, so x times 1 is x. So that's why this one works. You'll get all, this will be in other notes too. So don't stress.
The notes last time, actually. For the work.
Oh, did he talk about it a little bit? Nice.
It's for some of the problems we had to move the exponent over in order to move
Don't
things
erase that last one that you just raised.
Are you telling me what to do?
Yes.
You can erase the other stuff. I already have that.
Thank you for your permission, Karen. I don't want to erase the other stuff. I want to erase this one. Okay. Look at page 173, and you got this.
I was close. Log B. What's after that?
Oh, actually, you won't get that. Yeah. There you go. You got this.
Oh,
This one's more fun looking. You ready? This one is really fun. If we have B and we raise that to the log base B of something else, so x in this context, that equals x. Now there's a caveat on this one. That's only if x is greater than 0.
Will this make sense to us later? As to why?
I would hope this, oh, it's the y? Well, yeah, we could figure this out. These are actually inverse properties of each other. But if the base here matches the base here, then this just goes as long as x is greater than 1. If it's negative or 0, this property don't work.
Raise B. Log of B.
So, see if we can talk through some of the pieces here. Because we can, I guess, in 2 minutes. I'm trying to think about how to convert this and whatever. Okay, so if I was to take this and convert it to it's in exponential form. If I was to convert it to logarithmic form, right? That would be the log base B, that's just this part, of x equals the exponent, which is this one, right? So log base B of x. So it's the same. And actually, there's another property that gives us this one. If the bases match, this is the exponential the way the exponential property is written like this. If I have a to the x plus, equals a to the y, then the exponents have to be equal, right? That's the exponential property. We've seen that before, probably, right? If the bases are the same. So same idea here. If we have log and the bases match, then the arguments have to match. X equals x. So this is why that one works. And now it's time to leave.